So in the last session we have discussed about analysis of the fully controlled converter, so analysis of the single phase semi converter. So in this session we are going to discuss some conceptual problems regarding that topic. So here it is the first problem. So let us see the first problem. So what is this? So identify the correct statement from the following statements. So what is the first statement here? The fundamental power factor of the semi converter is greater than the fundamental power factor of the full converter. Is it right or not? So let us see here. So we know that the fundamental power factor equal to cos alpha by 2. So for the semi converter it will be the cos alpha by 2. So right. So for the semi converter, so it will be the cos alpha by 2. So for the fully controlled converter, so it will be the cos alpha, right? The fundamental power factor is cos alpha. For the same firing angle, so it got the less angle. So when cosine of less angle will be the larger value. So here this statement is right here. So because cos alpha by 2 is always greater than the cos alpha for the same firing angle here. So now let us see the second one. So what is the second one? Line commutated inverter is possible in semi converter and fully controlled converter. So is it right? So what is line commutated inversion? So line commutated inversion is nothing but when alpha is greater than 90 degrees, the converter or rectifier will act as an inverter in case of fully controlled. So here, so for semi converter, the output voltage will not be negative for any of the firing angle. So but in case of fully controlled converter, for alpha is greater than 90 degrees, it acts as a line commutated inverter. So in semi converter, it is not possible. So it is a wrong statement. So it is a right statement. So and it is a wrong statement. Second one is a wrong statement. Now let us see the third one. So the displacement power factor is greater than the input power factor. Is it right or not? So let us see. So what is input power factor? So we have seen the formula for the input power factor. So what is input power factor? So input power factor equal to IS1 by IS. So that is distortion factor into fundamental power factor. Fundamental power factor. So here IS1 by IS is the ratio. So always the IS is greater than the IS1 RMS. So the source RMS current is greater than the fundamental RMS current. So it is always less than 1. So when it is less than 1, when it is multiplied with the cos by 1, so what happens? The displacement power factor is always greater than the input power factor. So it is a right statement. So now let us see the third one. So fourth one. So what is this? THD value is independent of the firing angle in both fully controlled and semi converter. Is it right or wrong? So we know that the THD of the fully controlled converter is 48.4%. So it is 48.4%. So for any firing angle, so it is the 48.4%. So in case of fully controlled converter, so it is the THD is independent of firing angle. So let us see the semi converter. So then the semi converter, so it is the function of alpha. It depends on firing angle. So here it is not depending on the firing angle. So this statement is wrong. So THD will be independent in the fully controlled converter. So here, so it depends on the firing angle. In semi converter, it depends on the firing angle. So it is a wrong statement. So option A and option C are the correct option. So let us solve the next question. So let us solve the next question here. So what is the next question here? So the fully controlled converter is driving the RLE load. From this diagram itself we can set that. So what is the RLE load? So E can be here. So if you observe here, it is a full bridge fully controlled thyristor rectifier. So it has the R value of 0.5 ohms. R value of 0.5 ohms. And so here the PV cell, the PV array, photovoltaic array always generates a DC voltage. So right, so it acts as a DC source here. So on this polarity, if you observe this polarity, it is connected in the opposite direction. It is connected in the opposite direction. So the PV array voltage of PV is given as 110 volts. It is 110 volts. And the power of the PV panel is 1000 watts. So power of PV panel is 1000 watts. 1000 watts. Now, so here the source voltage is given as 120 volts RMS, and we need to find the firing angle in order for the utility grid to absorb the PV array power. So what is the meaning of this one? So the PV array should supply the power to the utility grid. So the power direction should be in this direction. So for that we need to find the firing angle. So let us find the firing angle. How we can find? So from this we can find the I naught, right? So how we can find? So the I naught equal to, so we need to find the I naught. So VPV, so P power divided by, so it is a ratio between the power of PV panel, so divided by voltage. So which is equal to 1000 divided by 110. So what is the value of this one? So 1000 divided by 110. So it is 9.09. So it is 9.09. So amperes. So the next one is, so we got the I naught value. So we need to find the, so for finding the firing angle, so we know the expression for the output voltage. In fully controlled converter, what is the expression for output voltage? So V naught equal to 2 Vm by pi into cos alpha. 2 Vm by pi into cos alpha. How we can find the V naught? From the fundamental concepts itself, you can find the V naught. So here, so if you know the KVL, that is sufficient. So V naught will be here. So V naught equal to I into R at steady state voltage across inductor equals 0 here. So minus VPV. So let me write that expression. So I naught equal to, so V naught equal to, so I into R, I naught into R, so I naught into R, so minus VPV. So I naught value, got the I naught value as 9.09 amperes. So it is 9.09 amperes. So what is the value of resistance? The resistance value is 0.5 minus VPV. The voltage across PV panel, PV array is given as 110 volts. So let me find this. So 9.09 into 0.5, 9.09 into 0.5 minus 110. So it will be the minus 105.455, minus 105.455 volts. Now we got the V naught. What we have to find? So we need to find the firing angle. How we can find the firing angle? So we know the value of the output voltage. So V naught equal to, 2 Vm by pi into cos alpha. So how we can find the Vm? So it was given as Vs RMS is given as 120 volts. How we can find the maximum value? 120 into root 2. So it will be the 2 into, so Vm is 120 into root 2. So which is the 120 into root 2 divided by 2 Vm divided by pi into cos alpha. So we need to find the alpha here. So what is the V naught here? Minus 105.455. So let me find the alpha here. So it will be the minus 105.455 into pi divided by 2 into 120 root 2. So what is the value? So here it will be the cos inverse of, this one is, so we got the alpha as 167.446. 167.446. So now we got the alpha value. So we'll solve the next problem. So here the problem is single phase full bridge fully controlled rectifier. So the problem is related to the full bridge fully controlled rectifier. So on the output voltage and the pure DC current of 20 amperes, which means so that it contains the constant current as a load, so which is equal to I naught is equal to 20 amperes. So we got the I naught is 20 amperes and the load voltage is varying from the 100 to 200 volts. So that V naught minimum is given as 100. So V naught minimum is given as 100. So V naught maximum is given as, so 200 volts. So it is a 200 volts. Now, so here input voltage is given as 230 volts. Which is RMS value. Now we need to find the maximum value here. So V maximum equal to Vs maximum or V maximum equal to, so 230 into root 2. So now what we have to find here? We need to find the maximum reactive power. So maximum reactive power absorbed by the load. So what about the reactive power? So we know that reactive power equal to, so Vs1 into Is1 into cos alpha for the fully controlled converter. So where IS1 is the RMS value of the fundamental component of the source current. So here cos alpha is the firing angle. So let me find the IS1 first. How we can find the IS1? So IS1 equal to, so it is a fully controlled converter, so we'll get the square wave here. So it is a 2 root 2, so divided by pi into I naught. 2 root 2 divided by pi into I naught. So which is equal to 2 root 2 divided by pi. So into I naught value is given as 20 amperes. I naught value is given as 20 amperes. Let me find this. So 2 root 2 divided by, so 2 root 2, so divided by pi into 20. So which is 18 amperes. So which is equal to 18 amperes. So we got the IS1 as 18 amperes. So now we got the IS1. We need to find the alpha value. So alpha value. So for that, let me consider two cases here. So the first case is, let me consider the V0 minimum here. So let me consider the V0 minimum. So it will be the, so sine alpha. So it is not cos alpha, it will be the sine alpha because it is a reactive power. So here it will be the V0 minimum and V0 maximum. So now let me take these two cases here. So let me find the alpha 1 and alpha 2. So let me consider the V0 minimum. So it will be the V0 equal to, we know that V0 equal to 2 Vm by pi into cos alpha. 2 Vm by pi into cos alpha. So from this, so V0 is already given, which is equal to 100. So in the first case, V0, let me take the V0 minimum as 100. So 100 equal to, so 2 Vm, so which is the 2 into 230 root 2. So 2 into 230 root 2 divided by pi into cos alpha. So divided by pi into cos alpha. So let me find the alpha here. Let me find the alpha here. What is the value of alpha here? So here the alpha equal to 100 pi. So 100 pi. So divided by 460 root 2. So 460 root 2. So the value is, so 61.12. So the value of alpha is 61.12 degrees. Now we got the alpha 1 here. So alpha 1 here. So now let me find the alpha 2. Now let me find the alpha 2. So alpha 2 we can find for the 200 volts. Let me take the V0 as 200 volts. So 200 volts, which is equal to 2 Vm by pi into cos alpha, which is 2 into 230 root 2, 230 root 2 divided by pi into cos alpha. So let me find the alpha 2 from this. So if I find the alpha 2 from this, so I got the 15 degrees. So I got the, so 15 degrees. So here, if you observe here, so the reactive power formula will be the Vs1 into Is1 into sine alpha. So it will be the Vs1 and Is1 into sine alpha. So it will be the sine alpha, right? So here, to get the maximum value of the reactive power, sine alpha should be maximum. For that, we need to substitute the maximum value of the firing angle. We should choose the alpha value as 61.12 here. So from this, let me find the, so let me find the Q maximum value. Q maximum value. So for that, Q maximum equal to, that is reactive power maximum equal to Vs1 RMS, so which is equal to 230 volts into Is1 RMS, which is equal to 18 amperes into cos 61 point, sine 61.12. So let me find this, 230 into 18, so into sine 61.12. So it will be the 3625.12. So VAR, the reactive power is, so VAR. So here we have chosen the alpha maximum because for alpha maximum only we will get the maximum value of the reactive power. For example, if I substitute the 15 degrees, here, I will get the minimum value of reactive power. So let me solve the next problem. So what is the problem here? So it is a single phase, again it is a full bridge, fully controlled rectifier. So again it is a fully controlled rectifier. So here it was given as, so Vs is given as 230 root 2. So Vm is given as 230 root 2. So 230 root 2. And the load is RLE load, right? RLE load. Load is the RLE load. So here it is a fully controlled converter. So it is a fully controlled converter. So and load is RLE load. Load is the RLE load. So load is the RLE load. So here it is the AC source. So this is the problem was given. So what is the value of R? So the value of R is 4 ohms. The value of R equal to 4 ohms. And E equal to minus 80 volts. So E equal to minus 80 volts. E is given as minus 80 volts. And L is given as 40 millihenry. So L is given as 40 millihenry. Now what I have to find? Alpha was given as 30. So alpha is given as 30. So what we need to find here? So we need to find the power supplied by the load DC source E. We need to find the power supplied by the load DC source E. So we need to find the power from the DC source. So we need to find the power from the DC source. So which is equal to power from the DC source equal to E into I naught. E into I naught. So we know the E value. So we need to find the I naught. How we can find the I naught here? So simple KVL is sufficient. So here it will be the V naught. So V naught. So R, this is the R value, and the current flowing, this one is I naught. So let me write the simple KVL expression, that is sufficient. So V naught equal to I naught into R plus E. I naught into R plus E. Here, so we don't know the V naught value. So let us find the V naught value here. So how I can find the V naught? So V naught equal to 2 Vm by pi into cos alpha. 2 Vm by pi into cos alpha. So we need to find the 2 Vm by pi into cos alpha, which is equal to 2 into 230 root 2. So divided by pi into, so what is the value of alpha here? So alpha was given as 30 degrees. So which is the cos 30 degrees. So let me find the value of V naught. So let me find the value of V naught. So which is equal to 2 into 230 root 2. So 2 into 230 root 2. So divided by pi. So into cos 30. So cos 30. So I got the V naught as, so 179.33. So 179.33. So if I know the V naught value, I can find the I naught value. How I can find the I naught? So V naught is equal to 179.33 plus I naught 33, which is equal to I naught into, so what about R value? So the R value is given as 4 ohms. R value is given as 4 ohms, right? So E is given as minus 80 volts. E is given as minus 80 volts. Let me find this. So let me find the I naught from this. So I naught equal to, so plus 80 divided by 4. So I naught equal to 64.83. So I naught equal to 64.83. So now what we have to find here? So we know the E value and I naught value. Now we need to find the power. So power equal to E into I naught. So E is 80 and I naught is 64.83. 64.83. So into 80. So I got the value as 5186.6 watts. So the power supplied by the DC source is 5186.6 watts. So now let me solve the next problem. So observe the problem. The next problem here is, so it is alpha is given as 90 degrees. So let me write the data here. So alpha equal to 90 degrees. So or else let me mark here, alpha equal to 90 degrees. So Vs equal to 200 volts. RMS value of the source voltage is given, which is 200 volts. So what about the maximum value? So the maximum value will become 200 into root 2. 200 into root 2. So now, so what about the R value? Here the load is R and E load. Load is the RE load. So here the load is RE load. So it is again fully controlled converter. So the load is RE load. So nowhere it was mentioned, but it is for the fully controlled converter. So here, so load is the RE load. So R is given as 10 ohms. And E is given as the minus 10 volts. Now we need to find the battery charging current. We need to find the charging current I naught. So how I can find the I naught here? So here, observe here. So here we know that, So we know that. So this fully converter we can replace with the 4 switches, that is T1, T2, T3 and T4. So here this is the VAB. So VAB, that is Vm sin omega t. So it will be the VBA that we have discussed earlier. So VBA is the minus Vm sin omega t. So again it will be the VAB. Again it will be the VAB. So let me draw the minus 10 volts line also. So it will be the minus 10 volts line. So it will be this black dotted line is the minus 10 volts. Now we need to find the so load current waveform. We need to draw the load current waveform. How we can draw the load current waveform? So here the firing pulse is given at, at this instant, that is pi by 2. So at this instant at 90 degrees, so we have given the firing pulse. So what happens if I give the firing pulse here at this instant? The T1 and T2 will get into the conduction state. When T1, T2 will get into the conduction state, so what about the output voltage? The output voltage is equal to VAB. So output voltage is equal to VAB. So VAB is the red color line. Let me draw the VAB here. So up to where it will conduct? So until Vm sin omega t equal to E. So up to here it will conduct. So again, so at this point T3, T4 will be triggered. So what happens during that time? So up to that current is 0. When current is 0, so what about the output voltage? So output voltage is equal to minus 10 volts. So it will be the minus 10 volts. So again it will be T3, T4 will be get into the conduction state. So again it will be like this. So up to here it will conduct. So again it will be next triggering pulse here. So output voltage will be like this. So here we need to find, we need not to draw the output voltage also. If you can draw the output current, that is sufficient. So when will be the output current flows in this circuit? So here from 90 degrees to, so what is this angle? We need to find this angle. So up to here, so the current is flowing. So again the current is flowing from here to here. So from here to here. So again the current is flowing from here to here. So it is the 0 and it will be the 90. So let me find this angle. How we can find that angle? Where Vm sin omega t equal to E. So at this point the current extinguishes. So we need to find the theta here. Let me find the theta. So let me mark it as a theta. So theta equal to sine inverse of E by Vm. So let me find the theta value here. So what about the theta value? So theta equal to sine inverse of E by Vm. So the sine inverse of theta equal to sine inverse of E value is minus 10 volts. And Vm value is, so Vm value is 200 root 2, right? So 200 root 2. So from this, let me find the theta value. Sine inverse of, so 10 divided by 200 root 2. So it will be the minus 2.026. How we can represent this negative angle here? So observe here. So minus 2.026 means, so we have got this point, minus 2.026. But this point will be the pi plus theta. So which is equal to 180 plus 2.026. 180 plus 2.2026. So it will be the 182.026. Now we need to find the average current here. So how we can find the average current? So here, so let me find the average current here. So the average current is, so let me find here. So the average current is, so it is in between the 1 by pi. So what about the current here? So Vm sin omega t minus E by R. Vm sin omega t minus E by R is the current. So the average current. So here it will be the limits are 90 degrees to 182.02. So 182.02. So it will be the 182.026. So now we got the limits also. So into d omega t. So let me simplify this one. How we can simplify? So let me convert into, so radians also. I will write the radians here itself. So 90 means pi by 2, so I got this radian value is 1.57, so 1.57, so 182.02 is 182.02, so it will be the 3.176. So this radian value is 3.176 radians. Now let us simplify this and let us find the I naught value. So 1 by pi into r, so r value is 10, so 1 by 10 pi, so 1 by 10 pi. So and here it will be the Vm sin omega t, so here it will be the Vm sin omega t, Vm is 200 root 2, so 200 root 2, sin omega t is, integration of sin omega t is minus cos omega t, and limits we need to substitute that in degrees, so 92, so 182.02, so and the next one is minus e into, so so e value is minus 10, so it will becomes the plus 10, so plus 10 into, so we need to substitute here in the radians, so omega 2 here, so because it's a number, so we need to substitute in radians, so that is 1.572, so 3.176. So let me substitute upper limit and lower limit. So after substituting all these values, I will get the I naught as 9.508 amperes. So 9.508 amperes. Now let us solve the next problem. So here it is the problem. Here, observe here. So what is this problem? So it is a full converter, single phase full converter. So it is a single phase full converter. So 230 volts 50 Hz, and the load current is given as constant value which is equal to I naught. Load current is given as constant value which is equal to I naught. So what we have to find here? Input displacement factor. We need to find the input displacement factor. So our fundamental power factor, which is also called as fundamental power factor. So and we need to find the input power factor. How we can find the input power factor and input displacement power factor? So we'll see here. So it is a fully controlled converter. So if I draw the IS waveform, how it will be? So let me draw the IS waveform so that you can understand easily. So IS waveform will be like this. It will start from alpha. So it will start from alpha to pi plus alpha. So here the fundamental displacement factor equal to, in case of fully controlled converter, so it will becomes the cos alpha. So that is IDF equal to cos alpha. So that is input displacement factor equal to cos alpha. Let me find the cos alpha. So we have the alpha value as 60 degrees. So observe here, alpha value is given as 60 degrees. Cos 60. So it will be the cos 60. So cos 60 is 0.5. So input displacement factor equal to 0.5. So it may be the option C or option D. Let me find the other parameter also. So which is equal to input power factor here. So what is the formula for input power factor? So which is nothing but distortion factor into input displacement factor. So input displacement factor already we have found, which is equal to 0.5. How we can find the distortion factor? So which is equal to IS1 divided by IS. So IS1 we need to find. So what is the meaning of IS1? So it is the RMS value of the fundamental source current. RMS value of the fundamental source current. How we can find the RMS value of the fundamental source current? We need to find, so I naught is given as 10 amperes, right? I naught is given as 10 amperes. So IS1 equal to 4 I naught by pi. So 4 I naught by pi into root 2. So 4 I naught by pi into root 2. So which is equal to 4 into I naught is given as 10 amperes, pi into root 2. So pi into root 2. So which will be the 40 divided by, so pi into root 2. So which is equal to 9 amperes. Nine amperes. So we got the IS1 as 9. So let me find the IS. So IS is given as 10 amperes, which is equal to load current, which is equal to, so IS RMS equal to 10 amperes. So we got the IS RMS equal to 10 amperes, which is equal to I naught. So now, so let me find the distortion factor. Distortion factor equal to IS1 divided by IS. So IS1 is 9, IS is 10. So 9 by 10 is 0.9. So 0.9 into 0.5 equal to 0.45. So which option is correct? So the option D is the correct option. Option D is the correct option. So now let us solve the next problem. So let us solve the next problem. So here it is the same problem, but it is semi-converter. If you observe here, so it is a single phase semi-converter. Single phase semi-converter. So and what we have to find? So here also we need to find input displacement factor and the current distortion factor. Current distortion factor. How we can find? We will see here. So let me draw the semi-converter output current, source current. Semi-converter source current. How the semi-converter source current? The source current of the semi-converter will be like this. Alpha to pi. So and pi plus alpha to 2 pi. So pi plus alpha to 2 pi. So this is the source current waveform for the semi-converter. So I0 is given as 10 amperes. Again I0 is given as 10 amperes. Let me find the input displacement factor. So what about the input displacement factor? So we know that the fundamental component will be like this. So, right? So it is alpha by 2. So it is alpha by 2. So it is a input displacement factor equal to, in this input displacement factor equal to cos alpha by 2. Cos alpha by 2. So cos alpha by 2. So what is cos alpha? Alpha is given as 30. So which is cos 30. So cos 30 is 0.866. 0.866. So in this option A and option B, it is in between the option A and option B. Let me find the current distortion factor also. So how we can find the current distortion factor here? So the current distortion factor equal to, so current distortion factor equal to, so IS1 divided by IS into IS1 by, so it is current distortion factor equal to, so RMS value of the fundamental source current to the, so it is the RMS value of the source current. Let me find the IS1 here. So IS1 here. How we can find the IS1? So it will be the 4I0 by, so pi into cos alpha by 2 divided by root 2. So divided by root 2. So here it will be the, so 4I0 by pi into cos alpha by 2 is the maximum value of the IS. So divided by root 2 will get the, so RMS value. Let me find this. 4I0 is the 4 into 10. So which is the 40 divided by pi root 2, so root 2 pi into cos 30 degrees. Cos 30 degrees. So what is the value of this one? So 4I0 by root 2 pi, that is 40 divided by root 2 into pi. So 40 divided by root 2 into pi into cos 30. So into cos 30. So it will be the 7.79 amperes. So it will be the 7.79 amperes. So now we got the value of I0 as 10 amperes. So but here, observe here, how to find the IS. This value is, so it is alpha and it is pi, right? So alpha is given as 60 degrees. Alpha is given as 60 degrees. How we can find the RMS value here? Observe here. So pi minus 60 degrees. 180 minus 60 is 120. So this width will be the 120. How I can find the RMS value from this? So IS RMS equal to, so 10 amperes into square root of pi minus alpha, that is 120 divided by 180. So 10 into square root of 120 divided by 180. So 12 by 18. So it will be the 8.164, 8.1649 amperes. Now we got the, so IS value, IS1 RMS. We can find the, so current distortion factor. So from this we can find the current distortion factor. So how we can find the current distortion factor? So IS1 by IS. So which is equal to 7.79 divided by 8.1649. So which is equal to 0.954. 0.954. So here the option will be the option B is the correct option. So option B is the correct option. So observe here. So IDF is the 0.866. Current distortion factor is the 0.955. So let me solve the next problem. So what is this problem? So here the topology here is, so here 3 diodes has given. So 3 diodes has given. And 1 thyristor has given. So what we have to find? We need to find the average output voltage. For that we need to draw the waveform, output voltage waveform. So let me draw the output voltage waveform for this first. So let me draw the output voltage waveform for this. So the output voltage waveform is, so V0 is here. So let me draw the output voltage. So here that let me trigger the T1 at firing angle alpha. So that is Vs equal to firing angle alpha is given as 30 degrees. At 30 degrees we are triggering the, so at 30 degrees we are triggering the, so here T1. So T1 is triggered at 30 degrees. So when T1 is triggered during the 0 to pi, the T1 and D2 are in the forward bias. So here it is triggered at 30 degrees, so that during the period 30 to pi it will be the VAB. 30 to pi it will be the VAB. So on the remaining period, so D3 and D4 will be forward bias. When D3 is on, automatically T1 will get turned off. So when D4 is on, D2 will get turned off. So that, so in the remaining period from pi to 2 pi, so pi to 2 pi, so it will be the, so from pi to 2 pi, so from pi to 2 pi, so D3 and D4 are in the conduction state. So what will be the output voltage? So it will be the VBA. So it will be the VBA like this. The output voltage will be like this. So again it will be like this. So how we can find this one? This is the VAB. So let it be the A terminal and let it be the B terminal. So and it will be the VBA. So VBA is the minus Vm sin omega t. So from this we can find the average voltage easily. So how we can find average voltage? So let me find the average voltage expression for this. So average voltage expression equal to, so V naught equal to, let me represent as a alpha here. So V naught equal to, so 1 by 2 pi. So integration of alpha to pi, it will be the Vm sin omega t. So Vm sin omega t into d omega t. So it will be the Vm sin omega t into d omega t. So from pi to 2 pi it will be the minus Vm sin omega t. So from pi to 2 pi, so it will be the minus Vm sin omega t into d omega t into d omega t. So now let me substitute here. So it will be the Vm will comes out. So Vm by 2 pi. So Vm by 2 pi into, so integration of sin omega t is minus cos omega t. If I substitute lower limit as alpha and upper limit as pi, I will get the 1 plus cos alpha, right? 1 plus cos alpha. Here, so the lower limit is pi and upper limit is 2 pi. So if I substitute in this minus sin omega t, so I will get minus of minus is, so I will get the 2 plus 2. So I will get the answer as, Vm by 2 pi into 3 plus cos alpha. Vm by 2 pi into 3 plus cos alpha. For the topology, the output voltage expression is Vm by 2 pi into 3 plus cos alpha. Let me find this thing. So Vm is given as, so here Vm is given as 100. So Vm is given as 100. So it will be the 2 pi, 100 by 2 pi, 100 by 2 pi into 3 plus cos alpha, 3 plus cos 30. 3 plus cos 30. So now you will see the expression for this. So 100 by 2 pi, so 100 by 2 pi into 3 plus cos 30, 3 plus cos 30. So it will be the 61.52. 61.52. So 529 volts. So now let us solve the next problem here. So here it is. So if you observe, it is a single phase bridge converter, fully controlled bridge converter. So because it has 4 thyristors, so here the input voltage is given as 230 volts RMS. So from this Vm equal to 230 into root 2. 230 into root 2, right? So what we have to find here, so R value is given, it is given as RE load. So RE load is nothing but, so internal resistance of the battery is given as 2 ohms. So it is given as 2 ohms and the battery voltage is given as, so battery voltage is given as 200 volts. Battery voltage is given as 200 volts. Now what we have to find? So observe here. So what we have to find? So here if SCR2 gets open circuited, so then what will be the average output voltage? So what will be the average charging current? We need to find the average charging current if SCR is open circuited. If one of the SCR is open circuited, so observe here. So observe this circuit. If SCR2 is open circuited, what happens if SCR2 gets open circuit? So this SCR will get open circuited. So it will not into conduction state. So which of the device will get into the conduction state? T1 and T4 only. So because if SCR2 will get open circuited, so automatically the current will not flow through the T3. So this will also in the open circuit. So now let us find for this topology. So let us find for this topology. So here, so E is given as 200 volts. So E is given as 200 volts, right? E is given as 200 volts and Vm is 230 root 2. So E value is given as 200 volts. Let it be the theta. Let this angle will be the theta. So let this angle will be the theta. So here T1 and T2 will get into the T1 and T4 will get into the conduction state. So these two devices will get into the conduction state. So when these two devices will get into off position, so here at this stage again Vm sin omega t equal to E, the current flowing through the device will be 0. So when current is 0, we know that thyristor will get into the off state. So at this stage it will be in the off state. So it will be the pi minus theta. Pi minus theta. Now the current is flowing from here to here. So after that, so will current flow in this duration from here to here? So will current flow in this duration? So the current will not flow because so the T2 will get into the open circuit, so that the current will not flow in this direction. So in this period. So here from here to here it will be like this. So for finding the average current, we need to integrate in between the theta to pi minus theta. Theta to pi minus theta. So let me find this. So theta to pi minus theta. So theta to pi minus theta. So I need to take the theta to pi minus theta as a limit. So the duration will be, we should take the 2 pi as the duration. So 1 by 2 pi theta to pi minus theta. So Vm sin omega t. So Vm sin omega t minus E by R into d omega t. So I naught value is, instantaneous value is Vm sin omega t minus E by R. So it will be the expression. Let me find from this. So let me derive this expression. So it will be the 1 by 2 pi R. 1 by 2 pi R. So into Vm. So into Vm. So right. So Vm into sin omega t. Sin omega t is nothing but, so integration of sin omega t is minus cos omega t. So and we are substituting the limits as theta and pi minus theta. Cos pi minus theta minus of minus cos theta will be the 2 cos theta. So it will be the 2 Vm cos theta. 2 Vm cos theta. So and minus E into d omega t. So minus E into pi minus theta is the upper limit, omega t will come here. So pi minus theta is upper limit and theta is the lower limit. It will be the pi minus 2 theta. Pi minus 2 theta. So now we got the average current expression. So let me find the, so now we got the average current expression. Let me find the theta here. We know the theta, we don't know the theta value here. So let me find the theta. So theta, how we can find? When Vm sin omega t is approaches to E. So when Vm sin omega t equal to E, there we are getting the theta value. So theta equal to, so when Vm sin theta equal to E, so sin inverse of E by Vm. Sin inverse of E by Vm. So let me find this. Sin inverse of theta equal to sin inverse of E value is given as, so what is the E value here? 200 volts. E is 200. So what is the theta value? So the theta value here is, so the Vm value here is, so 230 into root 2. So 230 is RMS value. So which will be the 230 into root 2. So let me find the theta here. So theta equal to shift sin inverse 200 divided by 230 root 2. 230 root 2. So I got the value as 37.94. 37.94. So if theta is there, so let me substitute. I have all the remaining parameters. Let me substitute in the equation. So I will get the I naught value. So I naught equal to 1 by 2 pi R. So 1 by 2 pi into, what about the R value? So the R value is given as 2 ohms. So it will be the 1 by 2 pi into 2. So into 2 Vm. 2 Vm is nothing but 2 into 230 root 2, which is the 460 root 2 into cos theta is cos 37.94. Cos 37.94. Right? So minus E. So minus 200 into pi minus 2 theta. Pi minus 2 theta. So here we need to substitute in radians. So most of the people will make the mistake here. So don't confuse here. It will be the radians. If it will be the radians. So it will, let me convert into radians. 37.94. So into pi by 180 we will get the radians. So it will be the 0.662 radians. 0.662 radians. So let me write the 2 into 0.662. 0.662. So now if I find the I naught value, so I will get the 11.89 amperes. So the option C is the correct option. So now, so in this case we have solved the different problems regarding the analysis of the fully controlled and semi-controlled converter.